Good evening, viewers. Hope you are all doing well. It's another episode for furtherance of our classes in chemistry. Today, being the 19th of October 2025, I want to wish you a happy Sunday across the world. This is also your one and only Prof Gee, chemistry with Prof Gee. Today, we want to talk about something very important with respect to understanding concentration. There's virtually nothing you will want to do with respect to chemical analysis or laboratory work that will not be narrowed down into preparing solutions or preparing stock forms of solutions to be diluted for further analysis. So it is important to understand what concentration in its ordinary form would mean. So let's begin with what we have here, understanding concentration. In a simple way, you can always put anything that comes as a solid, for instance salt or perhaps a sugar, in water. And if you dissolve sugar or salt in water and you stir, you already have a solution. It's a combination of solute plus solvent. The question is, how much of the solute do you have in the solvent? In chemistry, we are addressing this issue based on the amount of substance A that you have in another substance B and giving us a totality of the solution. There are two major forms of concentration. It could be molar concentration or it could be percentage concentration. Most importantly, molar concentration happens to be one of the most common types that we use in laboratory work. And percentage concentration may go as far as just understanding to what extent have you prepared the solution in equating it to 100%, or for instance also preparing a solution and understanding that the whole sum solution is equivalent to 100 or 100 unit or 100%. So sometimes we can also use this as well, but the most common one is in terms of molar concentration. So we have different forms of molar concentration. It could be molarity in terms of M, capital M. Sometimes some people say it is moles per dm3. We have also molality, also M2, but you also know that during calculations. I've seen some calculations where this can also be given, let's say, a capital C. It depends. We could have molality as M, capital M, or C. We also have mole fraction. This is also very, very important with respect to you adding two or more solutes in a given solution or in a given solvent. We have normality, which is N, capital N, and we have mass concentration, which is capital M subscript C. In our next class, I'll be talking to you about how these forms of concentration can be used in calculations. I'll also be explaining to you the relevance and importance of each of these concentration type. But please be rest assured that in a nutshell, concentration refers to a possibility or a process of having one substance in another. Most often you will have a substance dissolving another substance, and by the time you have this solute dissolved in the solvent, you have a bulk condition of the solution. So in the next class, we'll try to break down all of these and then also see how relevant calculations can be done using each of them. Have a nice day. Subscribe to our YouTube channel.